You ship a feature, the API bill lands, and Kimi just cost you 6 times what DeepSeek would have charged for the exact same output tokens. Both are frontier-class coding models, both open weights. So the real question is, which one do you actually pick when your budget and your codebase size are both on the line? Test 1. Cost. And here's a number that'll wake you up fast. You're running a product that burns through 10 million output tokens a day, which is pretty normal for any serious API workload. At Kimi's rate, that's $25 a day. At DeepSeek's rate, it's $4.20, and that gap compounds every single day into real money by end of month. I pulled both official pricing pages, and the numbers aren't close. Kimi charges $2.50 per million output tokens. DeepSeek charges 0.42, which is about 6 times cheaper, and that's straight from the vendor docs, not a community estimate. On cash-a-hit input tokens, DeepSeek is 5 times cheaper too, so the gap holds across the whole pricing stack. Now, Kimi does consume tokens more efficiently on some workloads according to community reports, so the raw per-token price doesn't always tell the whole story. That said, even if Kimi used 20% fewer tokens on average, DeepSeek is still way cheaper. The 6 times gap on output pricing is too wide for efficiency gains to close. DeepSeek takes cost, and it's not subtle. I expected a price gap, but 6 times cheaper on output tokens is way bigger than I'd have guessed from the marketing. And that puts DeepSeek on the board first. Kimi 0, DeepSeek 1. I've been living inside these APIs long enough that a pricing page is the first tab I open, not the last. Drop a comment if that cost gap has already bitten you on a real project. Test 2. Coding benchmark performance. Okay, so the objection you probably already have is, sure, DeepSeek is cheaper, but does it actually write better code? SWE Bench Verified is the benchmark that measures real-world software engineering tasks, not toy problems, and it's where the coding quality gap, if there is one, shows up clearly. I went through the official vendor benchmarks and the community numbers. Kimi K2 scores 67.1 on SWE Bench Verified. DeepSeek v3.2 scores 65.2. That 1.9 point lead holds across Aider Polyglot and Human Evil 2, though Human Evil is community reported, so treat it as directional. Both are genuinely frontier class, but Kimi is consistently ahead, just not by a huge margin. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. Kimi takes coding benchmarks, and I didn't expect the lead to be this consistent across 4 separate tests. That ties the score up. Kimi 1, DeepSeek 1, and now cost and coding accuracy are pulling in opposite directions. Test 3, speed. So here's the failure mode that actually hurts in production. Your coding agent is chaining calls, waiting on each response before it can fire the next one, and a slow time to first token on every single call stacks up into real latency your users feel. At 150 tokens per second versus 120, that difference compounds fast across a long agentic run. Put the numbers side by side and the direction is pretty clear. Community reported throughput has DeepSeek v3.2 at 150 tokens per second, Kimi K2 at 120. Time to first token is 0.6 seconds for DeepSeek, it's 0.8 for Kimi. These are community figures, not official benchmarks, so treat them as directional, but they're consistent and they all point the same way. These are community reported numbers, not official vendor data, so the exact figures can shift with server load. That said, the throughput gap and the latency gap both favor DeepSeek, and when you stack that speed edge on top of the price edge, DeepSeek's cost per useful token per second is pulling even further ahead than the raw pricing alone suggests. DeepSeek takes speed too, and I was expecting the gap to be closer given how new Kimi K2 is, but 150 versus 120 tokens per second is a real, consistent difference. Score is now Kimi 1, DeepSeek 2, so right now DeepSeek is ahead on price and speed. But there are still 2 dimensions left, and one of them, context window size, could completely change the math for anyone working with large codebases. If your repo is big enough that a 128K window just doesn't cut it, the whole calculation flips, and that's exactly what we're about to find out. Test 4, context and output limits. So 256,000 tokens is the number on the screen right now. Load a large monorepo into your coding agent, and if your context window fills up before the model has seen the whole codebase, it starts hallucinating connections between files it hasn't read. That's a real failure mode, not a theoretical one, and the window size is what determines whether you hit it. I checked both official docs and the difference is clean. Kimi K2 supports a 256K token context window. DeepSeek v3.2 caps at 128K. That's double the context, straight from vendor documentation. Max output is 8K tokens for both, so that part is a wash, but the input window is where Kimi has a genuine documented structural advantage. Most everyday coding tasks fit comfortably inside 128K, so for a lot of people, this advantage just doesn't come up. But if you're doing large codebase analysis, dependency tracing across a big repo, or feeding in long test suites, that extra 128K goes from optional to pretty much required, because the model either sees the whole picture or it's guessing at half of it. Kimi takes context, and the 2x window size is a clean, documented win that I didn't expect to matter this much until I thought through agentic codebase workflows. That evens things back up. Kimi 2, DeepSeek 2, with 1 test still to go. Test 5, deployment and modality. So here's the failure mode I hear about a lot. You pick a model, build your whole pipeline around it, and then find out it's closed weight and you can't self-host, so your data leaves your infrastructure on every single call. For a production coding agent touching proprietary code, that's a real problem, and it's worth knowing upfront which model actually lets you run it yourself. I went through the official documentation for both. Kimi K2 is open weights and self-hostable. DeepSeek v3.2 is open weights and self-hostable. Both are text only, no multimodal input on either side. The deployment story is genuinely identical, which is actually a good outcome for anyone who needs to keep their code on their own hardware. The parity here is real, not a cop-out. Both models are genuinely open weights with self-hosting available, so if data sovereignty is your concern, neither one forces you to the cloud. The decisive split lies entirely in price, speed, and codebase size, not in deployment flexibility. Deployment is even across the board. Final score, Kimi 2, DeepSeek 2, 1 tied, and the winner comes down to what you actually need from your coding model. Alright, so here's where Kimi is the clear pick. It scores 67.1 on SWE Bench verified versus DeepSeek's 65.2, and that lead holds across every coding benchmark in this comparison. It also doubles the context window at 256K tokens, which is a hard structural advantage when you're analyzing a large codebase and 128K just doesn't fit the whole thing. And here's where DeepSeek is the obvious choice. Output tokens cost 0.42 LARM per million versus Kimi's $2.50, which is about 6 times cheaper, and it's also faster at 150 tokens per second versus 120. For high-volume API workloads where you're paying that bill every single day, DeepSeek's combination of lower price and higher throughput is a pretty hard case to argue against. If your code base is huge and you need every point of coding accuracy, Kimi is worth the premium. But if you're running high-volume API calls and that 6 times output price gap is going to show up on your bill every single day, DeepSeek is the default pick. One thing the docs don't spell out: neither platform publishes specific quota limits or rate caps for API tiers, so you can hit a hard ceiling mid-run without any warning. I couldn't find verified figures for either. Build in retry logic and exponential backoff before you go to production, or a busy agent will just stall silently at the worst possible moment. If you're still figuring out which image model to pair with your coding workflow, I did a full head-to-head on Ideogram versus Midjourney, which is better, and the result there is just as close as this one. Worth a watch if you're making that call.